So this is the message structure of the all diameter messages. So it's split into the concept of a header, which is a fixed length header, and then AVPs, which are attached into the header. So, version, everyone likes to put a version in there. That's now version 1. Message length, 24-bit to put the message length. And the message length is all of this. It's not what follows. Okay? Some protocols do message length is what comes afterward. This is the entire message you have. There's command flags, which I'll go through next. The command code is the message. So is this a cabality exchange? But it's not the R. It's only the CE. Because the command flag tells you whether it's a request or an answer. And it's not response, it's answer. Request, answer. Okay? So through a transaction, the command code would stay the same. Okay? Application ID. So again, that's the application ID of what we defined. 1, 2, 3, 4, 5. Hop-to-hop identifier. I'll explain that. An end-to-end identifier. And then you've got your AVPs. And the AVPs are broken then down into AVP code, some flags, the length of the AVP, again, the whole AVP. And then you've got the vendor ID, which I'll talk about vendor ID. So 3GPP has its own vendor ID. So it has a set of AVP codes set against the vendor. Okay? Now this is optional, and you'll see within here there's a flag which defines whether this field is here or not. Okay? And then you have your data, which obviously can be the length of this, AVP length minus the top bit. Now the key thing to remember about 32-bit is that this always has to be 32-bit. So even though you've got maybe only 8 bits of data put in it, you add padding. So you would add 4 bits of padding, 3 bits of padding here. You don't only ever send 32 and then 8 bits and change the length. It's always at a 32-bit boundary. And this AVP length tells you the length of the actual data within here. Okay? Because you always know it's on a 32-bit, so if your length is 1, this, it defines it as 1, you know that your real length of the message to go on to the next byte will be 32 bits on. Okay? Any questions? So very quickly about how they define the messages. Lots of protocols use different ways of mandatory, variable, variable fixed, mandatory fixed, etc. They have a particular way of defining within all how their messages look. So they have the name of the message, CER, capability exchange request. It's the diameter header. The value of the command is 257, and the flags are set to be request. Okay? And then these are all the AVPs which they have defined it can support. I can add any other AVPs in because it has this little thing at the bottom saying AVP. So you've got here brackets saying that's mandatory, so within this message, that's mandatory. And I have min, star, max. So if I want to say they have a minimum of stuff in them, okay, and they can be repeated, then obviously that's 1, it's got to have a minimum of 1, it can be repeated, you can have as many as you like. If you put a max there, so if there was a 2 there, it meant you could have 1 or 2. Okay? Then you have, these are optional. As we see, these can all be repeated. But there doesn't have to be one of them, it can just be repeated on that side. There's another one which doesn't show here, is you can have a square, this kind of bracket, which says it's in a fixed position. Because all of these don't have to be in these order. They can be in any order they like. But if it's got a arrows of death around it, it means that it is fixed in that position, which kind of shows this here. This is always fixed. The header is always fixed in a position. And it's usually the session ID is usually the first AVP you come to. So that's the definition of that. So you've got the request flag. If this is set, the message you request, else it's an answer. Okay. You have the E bit is to say answer is a protocol error. So the protocol error is usually done by the next hop to say that there's something wrong. I can't handle this message. And it has a result code of 3xxx, which I go on about the result codes and how they're segmented into different areas. But you would set that flag to say that I've rejected back. Proxiable indicates the request is proxiable. So in the base protocol, there's 5 or 6 messages which you don't proxy across the other end, because you're using them to keep your connection alive. But of course, if you're sending end-to-end messages, then those are proxiable. So that bit would be set to say yes, obviously proxy that through. The retransmit is a flag which the failures are basically operated on that you send a request to the other end, and if you need to send another request to get to, so from client to a server, I'm going to send you a request. If I want to retry, I can retry again if I want to. But if you send another one, you put the retransmit flag on to give the other end indicator that that's a retransmitted message. And you can also use different paths to get through, but you set that T bit. Because the concept is that you have these two identifiers. The hop-to-hop identity is the identity to go between the hop-to-hop, if you like, between the client and the peer connections. So obviously, because these protocols you can send many messages in, and you can get many messages back out, and you have to know which answer is related to which request. So you do that with a hop-to-hop. Then there's the part of the session, or the actual, what you're trying to find out from the server. Use the end-to-end identifier. So the end-to-end identifier is between him and him, so he can tie up his requests and answers. But this one to this one wants to know what he's got in, etc. So as you see, the hop-to-hop changes between there, but the end-to-end remains the same across. Okay? So what the spec says is that this value should have a duration of 4 minutes. So what you're trying to say to the server is he's got one request in, he may have got it, he may not have got it. So that, with a T set, it knows that he can make an assumption it's associated with something he hasn't got something before, etc. But that session here should only have a duration, this value should only have a duration of 4 minutes. So that allows you to do lots of sending messages either down the same path or from a different path. It allows him to tie it together and understand if it's a retransmission or not a retransmission. Okay, AVP flags. So the AVP format, that was the flag to say that you've got the optional vendor specific bit, which extends the AVP code set to allow for an optional vendor ID field. M is mandatory. Now, that doesn't mean the same. What mandatory means is that if you get it, the person who has the server must understand what that AVP is. I've never quite got this concept. I understand the concept, but usually in protocols, people put an awful lot of stuff in it. And I'm saying, well, I only need to understand this little bit, and I've got everything I need. But you set a little flag on in the dictionary of the AVP and say, I must understand this. So, don't know, but hey, they thought it was important. And the rest are reserved, okay? So then you have in there the vendor ID as well, present in feed flag set, and the length of the entire AVP, including AVP. Okay? So, what they have done within the breakdown of the messaging of the AVP, they have done a fairly decent job of only saying you can only really have these basic AVP types. So if we all break down into looking at good old SS7, GSM, they will define an IE, and that IE could contain anything of little bits and bytes, mean different things depending where you are within the IE. Here they're saying you're either going to be an octet string, so the octet string is a string of octets with a length. You can have integer 32, which is a fixed length, 12 or 16, depending if you've got the vendor ID in there. 64-bit integer, unsigned 32, unsigned 64, float 32, float 64, and a concept of grouped messaging, etc. What they've also said, you can derive from the octet string other particular types of AVP. So they have the address, which the first two octets tell you what type of address it is. So is it an IPv4 address? Is it an IPv6 address? Is it? I think there's 20 or 30 different types of addressing it can be. The main ones obviously are IP address. Time, so 4 bytes, contain the UTC. UTF, so that obviously is derived from UINT32. UTF-8 string, human readable ASCII string, which is derived from here. Diameter identity, fully qualified domain name. So basil.squires.com, etc. basil@squires.com. Diameter URI, as an example of a diameter URI, which has got the fully qualified domain name, the port, the transport it's using, and the beta protocol it's doing. And then there's another one which is IP filter rules, which, if you're familiar with setting up networks, you'll understand them. If not, this isn't the place to do it. So yeah, it does make it a lot easier to decode, understand, to have protocols fitted in within this concept. And a lot of the reasons you can do this is because you're not caring about bandwidth anymore. You don't care how many bytes you waste. It doesn't matter anymore. It's not a thing. It does, but it doesn't. At the end of the day. So you can break down, so what you're doing is abstract. If you think how you would abstract SS7 ISAP, i.e. you would abstract it down into an object which was nature of address, type of address, etc. You can do that abstraction with a grouped AVP. So you can have your top one and then break that down into additional things which mean, to a grouped AVP, etc. So here's a grouped AVP. Simple concept is that you have an AVP within an AVP. Okay? Simple as that. So this contains a subset of abstraction of information which is provided into a separate AVP. You don't have to make it really complicated within the AVP of actually having all nibble bit thing encoding within the data field. Okay. The other thing they've done as well, which I think is fairly good, instead of using the concept of a fixed way of actually having your definition of your message set, you use the dictionary. So the dictionaries are used for defining the AVP data types, whether you've got enums associated with the data type. So if anyone's not familiar with what an enum means that an AVP can only have a set of values and they mean something. It isn't like having a number, which you can have from 0 to 3 billion. You can have an AVP which is 0, 1 or 2 as a value. Defining the AVP usage in a given message, whether within that message it's fixed, mandatory and optional, and this is usually defined in an XML format. And what we use is the Diameter Wireshark XML dictionary for all of our setup of our encoding and decoding of messages. So here's an example. Some very well-known AVP names. So for IP mask, it's a code of 9. It's mandatory. Somewhere protected. I won't go through encryption on this training course. The vendor bit, it hasn't got a vendor bit set. The type name is IP address. Then there's one with some enums in. It's the same concept here. It's got a code of 10, but it's got some enums in here, which is if the content is 0, it's none, 1, sending routing, 2, 3, sending listen. So if you think that what this allows our product to do, or anyone's product, if you have that XML, you can decode that XML, I can decode, encode, understand every new thing when something comes up. Not in the case of changing code to add new messages in. And in effect, all I've got to do is have the dictionary, because it's all fairly standard and straightforward. The code is worrying about data types. It's not worrying about individual how things are broken down. Okay? Any questions on this? So here's some of the important AVPs which you'll find within your messages. So original host, original realm is mandatory in all messages, and it contains the originator of the message request. Then you have destination realm, destination host, which is used in the request for routing, but it's not valid to have them in the answer. So the session ID, that is used as a unique session key across a session, where you've logged on, you want to do accounting, etc., through a whole session of your life, or be on the phone, you can use that session ID. Then you have a result code, so in the answer message, the result code telling you, yes, it happened, no, it didn't happen, the reason why it didn't happen, usual kind of error code handling. You also have root record, which is important. It's used to detect loops. So loops is always down to the case where you have individual devices having the ability to get their routing tables a bit wrong. Especially when you kind of go between networks. So he may have a path to go, he's trying to get the client to the server. He then goes, oh, there's my routing table, I go here. And he goes, oh, there's my routing table, I go here. And he goes, oh, I go back here. So what you want him to do is he detects through his root record, because he would have had, when he sends this message out, he adds the peer identity into this message, and each one keeps adding who they got it from. So when it comes back to here, when you try and route it again, you go, hang on, I've already got this from a person, etc. So it's used to take loops, adds incoming peer identity to outgoing request, and it just checks if local peer is in the incoming root record list, or if you're sending to a peer in the incoming root record list, rejects back. The original state is used to indicate that a connecting peer, that the system is being rebooted. Now the point of this is that if this goes down, let's say he sends a request in, this goes down, you're kind of saying, well, I've lost the ability to go back to him with that response. But when this connects up, this has on the CER and the response of the CEA, this has an AVP called original state ID, which remains constant through a non-reboot. So every time you reboot, you'll change it. So if he comes back up again, he goes, he's maintained all the states of his transactions, so if I get an answer back, I can send it to him. So again, what you have is the concept of a transaction has a particular life. So you can say a transaction has a life of a minute, okay? But you can have outages within that minute and still have the answer back. When he comes back and he says, no, I haven't rebooted, I'm still able to get the answer back, you can still send the answer when that connection comes back up again. So that kind of gives you another level of, you can see how it can get quite complicated with things retrying, rerouting, because you could still come up on this way and you could send the answer, but you may have got an answer through a different route. So these states here are defined pretty well to actually make sure you handle any other acknowledgements coming in on there. But that's the purpose of the original state ID. Okay. All the error codes, result codes are divided into separate categories. Sorry. So informational, informs the originator that request could not be satisfied, an additional action is required. There's only one. That's that. Down to multi-round authentication, which is telling you you've got to authenticate again. Okay. Success tells you whether the request has been completed. There's two, I think. There's done success, and I think there's a partial success as well. Protocol errors performed on this is on a hot-by-hot basis. That the protocol error has been detected. Each bit should be set for this category. So you've got diameter unable to deliver, diameter too busy, etc. Transient error, request cannot be currently be actioned but may be able in the future. So that's saying I can only go with that transaction if I wanted to. The permanent failures is saying I can't handle this request. This request is rubbish. Go away. Okay? But these are all very well published. You can go anywhere, Dinosaur Air Code, you'll see, I don't know, it's not many to be fair, 30 this week.